You have word problems this section. They're not terrible word problems. They're actually pretty easy, to be honest. Okay? It's just pretty much basic plug in, chug, and that sort of thing. You're going to have two types, and this kind of goes back with the growth and decay. So we're going to talk about it for just a little bit as far as the differences to that first slide. So if you're following along in your notes, I want you going back to this one. Okay? Now, I want you noticing how, your axes, your coordinate planes can represent real-life situations, but they only really represent them in the first quadrant, right? Because all your numbers are positive there. Once you go into word problems, you're talking about, if you go negative numbers, you're talking distance, amount. You can't have negative things. You can't be negative number of beetles or whatever the case may be. So you're typically talking about the first quadrant. So here, and on this one down here. Now, these are obviously two basic graphs, but they kind of resemble all of your different situations that you could have throughout these problems. For example, this one from left to right is going what? This graph. It's going up. Okay, from left to right, this one is going up, hence why they call these exponential growth functions. You're growing. Surprise, right? Okay. And then down here, you're going down from left to right, correct? So that's why they call them decay. Okay, you're decaying things. It's usually a slower process with decay once you get to these problems because, as you can see, the more and more closer you get to the x-axis, the lower and slower it becomes. Okay. So then going back to the word problems, the equations you're going to use look very similar to like these equations. Okay, you can kind of see the similarities to from there to here. You have two different ones, and if you notice them, they're very, very similar. The only thing that is different is the sign. Yeah, the sign that's in between. This one is a plus. This one is a minus. So the plus will obviously be with the growth. The subtraction one will be with the decay. All right. So anything that's growing, anything that's getting bigger, you're going to use this equation. Anything that's decaying, getting smaller, you're going to use this one. Let's see here. The functions can be used to find the amount after t number of time periods. Yeah, the variables stand for, t is your time, r is your rate, a is your initial. Some pretty basic variable representation there. Okay. And here's a little bit of vocab for you. The expression r plus or 1 plus r, this expression right here, that's called the growth factor. I don't know why my voice just cracked, but it did. And then your 1 minus r is called your decay factor. Okay, how much is it growing? How much is it decaying? Stuff like that. Okay, questions? As far as the execution of the word problems, they're pretty basic, okay, to figure them out. So the first U.S. Census was conducted in 1790. At that time, the population was 3,929,214. Since then, the U.S. population has grown by approximately 2.03% annually. Don't worry about this part, drawing a graph to show the population, but what we do want to do is estimate the population in 1890. Alright, so first thing to figure out, is the population increasing or decreasing? Increasing, okay, which means we're going to use the A of t equals little a 1 plus r to the t. We're going to use this function. Alright. Okay, now remember what your variables represent. This little a here, that's your initial amount. So initially, what's your population? 3,929,214, right? Okay, so 3,929,214. Parentheses, 1 plus. Your rate is what? What's the rate that it's growing by? 2.03 what? Percent. 2.03%. can you use percents in these problems? No, you have to change them to decimal numbers by moving the decimal place to the left how many times? 2 times. So what you want to use is 1 plus 0.0203. That was a terrible 0. Let's try that again. Much better. Okay. Now for the time, you got to be a little. The time is probably the trickiest part to this problem. Figuring that out. Okay. They wanted to estimate the population when? In 1890. They want to estimate the population in 1890, but when was the first census conducted? 1790. So what's the difference between those two? 100 years, right? It's been 100 years since the first census was taken versus the second one. Or whichever one they're talking about, not the second one. I'm sure there's one in between there, yep. Okay. But you're talking about the time difference between the initial to what you want now. So we started at 1790. We want to know 1890, which means your exponent should be what? 100. The years gone by from 1790 to 1890. And that's how you set it up. Okay. So once you have that set up, and I want to see that set up because I want to know you know where the parts go. I want to know you know what you're putting into your calculator. After that, though, I don't really need to see a whole lot of work. Okay? Because a lot of this you're going to do in your calculator anyhow. Okay? Any questions at this point? Everybody good? Let me write this down real quick so I don't screw it up. Okay, let's pause. Okay, so make sure when you plug this into your calculator, you follow your PEMDAS rules. All right, so 3,929,214, parentheses, 1 plus 0.0203, that's raised to the 100th power. What are you going to do first? Parentheses, which means 1 plus 0.0203, which is going to give us 1.0203. Then we're going to do what? Exponent, take that to the what power? 100th. Hit enter. And then we're going to multiply that by 3,929,214 to give us a grand total of grand total of 29,315,300.34 people. Okay? 29,315,300.34 people. Here's the question of the day. Ready? What do you do with this 0.34 of a person? Round it which way? Down. Yeah, round it down. Okay? I don't want to know a third of a person's alive. Okay? I don't want deformed people. I want whole number of people. Okay? So 29,315,300. Okay? All right, next one. A cup of green tea contains 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of the caffeine from their system per hour. Write a function that will represent the amount of caffeine remaining after drinking a cup of green tea. Then estimate the amount of caffeine in a teenager's body 3 hours after drinking a cup of green tea. Before we start this problem, I want to point something out that I didn't point out last problem. Bless you. All right? And that has to do with your time, okay? Let's back up this real quick. What was our time here? 100 years. Okay? Years, right? What's our time in this problem? Hours. Okay? Now, that's okay. Okay? Your formula doesn't change if one's talking about it in years and one's talking about it in hours. As long as within the problem itself, individually, your time frame stays the same. Okay? So as long as you're not talking like, minutes and hours in one problem, you're okay. Okay, so as long as this whole problem's in hours, or as long as this whole problem's in years, or this whole problem's in minutes, you're okay. All right? So this one, we are doing what with the caffeine? We intaking more? No, we're doing what? We're decreasing it, right? We're eliminating, whatever that means. You can fill in that blank. So A of t equals A, parentheses, 1 minus R to the t. Okay? So what's our little a? 35. 1 minus. What's the rate number? Good, 0.125. And then t is 3. Okay, plug that in your calculator. Do the apps or the programs rather, or run it through. Do it just without the program. Either way, you should end up with an answer of 23.4. Does it say what's around to? It doesn't. Let's go with hundreds. So 23.45 milligrams. Alright. Very good on that one. Okay. A substance decays 35% each day. After 8 days, there are 8 milligrams of the substance remaining. How many milligrams were there initially? After a substance decays 35% each day. After 8 days, there were 8 milligrams of the substance remaining. How many milligrams were there initially? I don't know why I'm yawning so much. This isn't boring. This is exciting. First off, are we growing or are we decaying? We're decaying. Okay, that's pretty easy. It says decay in the problem. So we have A of t equals little a, parentheses, 1 minus r to the t power. That's the equation we're going to use, okay? What rate are we decaying at? No, what rate? 35%, so we need to use 0.35, right? So 1 minus 0.35. What's our time frame? 8 days. Okay. Now, read the problem carefully. After 8 days, there were 8 milligrams of the substance remaining. How many milligrams were there initially? So what's different? We're kind of making it grow instead of decay. Okay, I see that. I see that logic, but we can. You're on the right track, Joey. You want to make it grow. We know the what. We know how much it. We know how much it decays, right? We know how much after 8 days we have left. What we don't know is how much we have initially, how much we start with, right? So we don't know this little a. Okay? We don't know that little a right there. But we know after all this, how much do we have left here? 8. Okay? Does that make sense, everybody? Because it's asking how many initially. This was the initial value. Okay? That's the initial. All right? Now, your programs won't work on this one. Okay, you gotta do this one by hand. Okay, but once again, see this setup. After that, you're pretty much going to go to your program or to your calculator rather. Sorry. Okay, in the same manner. Okay, so I'm going to keep it here on the screen. So first thing we're going to do is the parentheses, right? So 1 minus 0.35 gives us 0.65, right? So 8 equals a 0.65 to the 8th. Next thing we're going to do is take 0.65 to the 8th power. Okay, now watch me real quick. We're going to do this twice. Okay, so 8 equals. I'm going to round this number, okay, because 0.65 to the 8th is something really ugly. Okay, I'm going to go 0.0319a just to get it on the page. Okay, just to get it on the page. What I'm not going to do is clear that out of my calculator. Okay, the long real number, the non-rounded number. And I'll show you why in a minute. All right. On paper, my next step is to what? Trying to solve for a. Divide by? Okay, on paper, that's what my next step looks like. On calculator, though, your next step, you can't just divide this by just 0.0319. You need to divide this by 0.03186448813 and the rest of the numbers that are saved that you can't see. So what you want to do is go 8, divide, second, answer. I'm going to show you those keystrokes again. Okay, once I pull up the calculator method. All right. Your answer ends up being 251.06. Okay? About 251.06. Does the on paper make sense on the algebra to it, right? As long as that makes sense, we can go to the calculator and figure out how exactly I got that, okay? Everybody good? Pictures? Okay, so here's what I'm talking about. Let's clear this. Let's start fresh. Okay. We go 1 minus 0.35, right? That was our first step in the calculator. We hit enter. That gives us 0.65. We then take that to the 8th power, correct? Okay. That gives us 0.013 or 0.3186448813 and whatever else that's left there, okay? Now, if you were to take that number and round it, let's say I round it to what I wrote down on the paper, right? 0.0319. And you divided that into 8. It would give you 250.78. And our answer is 251.06. See, you lose when you round. Right? Has anybody taken chemistry? Yeah. Okay. Have you ever heard of significant digits? Yeah. I'm a math teacher. Every digit is significant no matter what. Okay? Which means all these digits after here are significant. The ones you don't see, they're significant. They all matter. Okay? Which means you can't just round it off where you want to and then go from there. Your answer is going to be so screwy after that, it's not even funny. It's not going to be close. So what you do is you round it so you write it on paper. Okay? You don't need to write this all down, but you leave this there in your calculator. Okay? If you looked at your work, your next step was do 8 divide by this number, right? So then you do that. So 8 divide by, and then this number, if it's the last thing you have as an answer, you always go, I don't know if I showed you this yet, you always hit second negative, and it'll bring that answer up. Okay? Kind of like how if you do 2 plus 3, you hit enter, it's 5, and then you hit plus 2 again, how answer pops up. Same thing, except now you're putting the answer second where it needs to be instead of first. Okay? You hit enter then, that gives you the answer you want. Okay? So make sure you can round it to write it down, that's fine, but don't round it and put it in your calculator. Okay, if you round it and put it in your calculator, your answer is going to be off. Like for example, 8 divided by what we put on the paper, 0.0319 to 50.783. Okay. Now, while that's not a lot, it's still enough. You know, and you can, depending on, like for example, I could do 8 divided by 0.03. That's 266. Holy crap! You're way off. You know, that's because you lost all of those numbers that were up here. Those point, whatever it was, point zero. My calculator just turned off. The point zero, the 186448113, and everything beyond that. Okay, this isn't chemistry. Every number is significant here, so you got to use them all. Okay. Questions on that, guys?